Alright, so today we're going to be looking at graphing linear functions, and we're going to be transforming these linear functions. Now, we've already looked at transforming linear functions by changing the y-intercept. We would move the line up or down. We called it a shift. And then we also looked at what happens when we change the slope and or our rate of change. So now we're going to look at a couple of other things. And the first thing we're going to look at is when we reflect the line across the y-axis. How does this look? What does it do to the equation? What does it do to our key attributes? That kind of thing. Okay, so you're going to need a pencil and a writing utensil of a different color. We suggest map colors, and there's some over on the bookcase if you need to go get one. You might want to pause the video and get what you need if you don't have those items already. Okay, so we're going to graph this first line, f of x equals negative 1/3 x, and then we're going to reflect the line across the y-axis, and then we're going to write the function. Okay, so starting off, we're just going to write down here f of x equals negative 1/3 x. Okay, our b value, remember, because we're using the slope-intercept form, the b is the constant being added or subtracted. And if we look out here after the x, there's no number written. So we know that that means that the y-intercept is 0, and it is written as the coordinate 0, 0. Okay, then m is the slope, which is found as the coefficient of the x, which is here negative 1/3. So we put these two pieces together and we begin our graph at 0, 0. And then we count negative 1/3 slope. And we have a choice. We can count up and to the left, or we can count down and to the right. Doesn't really make any difference. I'm going to start off by counting up and to the 1 and to the left 3. Up 1 and to the left 3. Again, up 1 and to the left 3. Since our line is continuous in both directions, we can reverse that now and go down 1 and to the right 3. Down 1 and to the right 3. Down 1 and to the right 3. Okay, and so there are the points that are we can put on this grid. So then we're going to take our straight edge. Mine looks a little different than yours, I'm sure, because mine's electronic and yours is actually a ruler or your ID badge or something of that sort. Okay, so then we're going to line up through our points and then take a moment to put arrows on the end to show that we understand that our line is continuous in both directions. Now, I didn't get mine lined up very well here, so you want to be careful with that. You have a little easier time with your ruler getting it laid down. I'm kind of eyeballing here. So, all right, now it says to reflect the line across the y-axis. So this is where we change our colors, and we're going to reflect across the y-axis. Now, hopefully you remember from your 8th grade math when you did transformations that a reflection across the y, we simply count to the y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we count away from the y-axis the same amount on the same line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and my new coordinate would be located there. You can also look at it this way. This coordinate was negative 9, positive 3. This coordinate is positive 9, positive 3. So what we're really doing is we're changing the x value to the opposite of what it was on the other side of the y-axis. So we're at negative 6, so we would be at positive 6. We were at positive 2, so we'll still be at positive 2. So 6 up 2. Whichever method you prefer, counting 1, 2, 3, 1, 2, 3, or by just knowing that since this one's at positive 3, 1, this one will be at negative 3, 1. Now, we have this point here in the middle. It's on the y-axis, so it is common to both lines. Okay. So I just keep counting. Positive 6, negative 2 means negative 6, negative 2. 9, negative 3 means negative 9, negative 3. And we have our line. And we put our straight edge to it. So there are our two lines, and now we have to write the function of g of x. So from the graph we can tell that the y-intercept is at 0, 0. So just like above, it didn't change. And our slope, well, we can count that out. We rise 1 and run 1, 2, 3. And we are going up, so it is a positive 1/3 slope. So we put that together, and we have 1/3 x plus 0, or you can simply leave it as 1/3 x. Okay, let's take a look at another. Okay, so we're to graph 5x minus 10y equals 20, then increase the y-intercept 2 units and double the slope. Okay, so if we're going to graph this equation, we've seen equations written in standard form before, and we chose to solve for y, and so that's still valid. You could also try to find your x and y intercepts, since we've done that as well. Based on the information we have to give, I think the best route would be to go ahead and solve for y, because we have to write the equation in the y equals form. So we start off with 5x minus 10y equals 20, and we want to get y by itself, so the x has to go, and we move it by subtraction this time. So 5x take away 5x is 0, and what we do to one side of the equal sign, we do on the other side of the equal sign. So now we have that negative 10y equals 20 minus 5x. Now we have to divide it up. So we divide by negative 10, which is the coefficient of y. And we have y equals negative 2 plus 1/2 x. And then to put it into the slope-intercept form, we'll write it 1/2 x minus 2. So b is the number being added or subtracted from x. So in this case, that's negative 2. So our y-intercept is at 0, negative 2. M is the coefficient of x. So in this case, the number with x is 1/2. Okay. It says then increase the y-intercept 2 units. So the y-intercept was negative 2. So an increase would mean we'd add 2 to the y-intercept. So now our y-intercept is going to be 0, or the point 0, 0. Okay. Then we look, double the slope. The slope was 1/2. To double means to multiply by 2. So 2 times 1/2 is 1. And since it's slope, we'll put it 1 over 1 so that we have the fraction form. It makes it a little easier when we're graphing. All right, so now we put all that together. I'm going to change back to my black because that's going to represent your pencil. All right, and we're going to start at 0, negative 2. And we have a slope of 1/2, so that means up 1 and to the right 2, or down 1 and to the left 2. And then we just keep carrying that out until we run out of space. And we reverse, go the other direction. We put our straight edge to it. put our arrows on the end. So there's our first line, y equals 1/2 x minus 2. Change to our color, other color. We have b is at 0. Our slope is 1, so we can rise 1, run 1. Rise 1, run 1. And we just keep going. Is this line looking familiar to anybody? We've graphed it a couple of times. Well, this is our linear parent function. Call the linear parent function. This is the line from which all other lines are derived. Okay. So it is the line y equals x, which we could put together from our given information. We had 1/1 x plus 0. 1/1 is 1, or which we don't have to write, and then plus 0. So there are two lines. We have now graphed the original line, which was 5x minus 10y equals 20, and then our new line, which is the linear parent function. Which best describes the effect of f of x equals 2x minus 1 if the y-intercept is increased by 4 units? Okay. So we have a graph here that we can use. You also have your calculators that you could put the information into. So if we look here, which best describes the effect, I think that's supposed to be on. That would be a better word there. The effect on if the y-intercept is increased by 4 units. Okay, so if we take 2x minus 1 and we graph it, then that means we're going to start here at -1, and we're going to rise 2 and run 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. And we just keep carrying that out. And we could go the opposite direction. 1, 2, 1. 1, 2, 1. 1, 2, 1. Okay, and we put our straight edge to it. Draw our arrows. Okay, so that's f of x equals 2x minus 1, and we're going to change the y-intercept, increasing it by 4. So we're going to add 4 to this line on the y-intercept. Okay, so our y-intercept is currently at -1. So if we increase by 4, we're counting up 1, 2, 3, 4. And that's all that's changing. So we're just moving every point up. 1, 2, 3, 4. It's like we're picking up the line and moving it up 4. So now let's look at our choices. It says the x-intercept increases. Okay, so we went from blue to red. We're moving that way. So here's my x-intercept, and it moved over to here. Is that an increase or a decrease? On the x-axis, as we go to the left, it is a decrease. So it did not increase. All right, the y-intercept. So we move from here to here. We're going up the y-axis. Is that a decrease? No, that's an increase. Okay. The new line has a greater rate of change. Let's see. This rate of change was up to 1, 2 over 1. And let's see our new rate of change. Up to over 1. Nope, it's not new. It's not greater. The new line is parallel to the original. Well, it should be this answer because we've eliminated the other choices. And as you can see, our line is 2 units apart at every point. So 2 units apart at every point means it's not going to ever intersect, which makes it parallel. All right, let's look at another one. Which best describes the effect on the graph of f of x equals 1/4 x plus 3 if the slope is multiplied by 8? All right, so the first thing we need to think about is the slope is being multiplied by 8. If we look at this equation, the slope is 1/4. So if we're going to multiply that 8 by 8, we get 8 times 1/4, which turns out to be 2. So my new equation, we'll call it g of x because g comes after f. Okay, so my g of x would be 2x plus 3. So what's going to happen? Is the y-intercept going to decrease? Is the y-intercept going to increase? Does the new line have a greater rate of change, or does the new line have a smaller rate of change? Okay. Well, just looking at the equation, we know that 4 and 2 are my rates of change. Okay, 1/4 and 2 are my rates of change, and 1/4 is smaller than 2, which means that my new line, g of x, has a greater rate of change than does my old line, which was 1/4 x plus 3. Second thing we can look at, and the reason we know it's not the y, is the only thing that changed was the slope, and my y-intercept stayed at plus 3. You can graph all that if you want to, if that would make it make more sense to you. I'm going to leave this graph and just go by the equation, and we know that the answer would be C. All right, so that's some transformations of lines. You're now going to work on graphing linear functions 5, which looks at transformations of lines.